Hello, today we're going to go over 3.4. The concept that we're going to be going over today, CPCTC, is something that we've already been doing throughout the chapter. We just haven't been using the vocabulary word for it yet. So we're going to prove that the corresponding parts of congruent triangles are congruent in this section. And that's what CPCTC stands for. You will need this when we are completing a couple of proofs, either on the review or the test. So it is important that you are reviewing this vocabulary word so you can remember it when you need it on the test or the quiz. So when two triangles are congruent, the corresponding parts of that triangle are then going to be congruent. So in a proof, first we have to show that the triangles are congruent, then we can say the corresponding parts are congruent. So remember, corresponding parts are the parts that are matching or lined up with the order of our letters when we name the parts. So we talked about how J and A, those are in the first spot of both of these names, so those two angles have to be congruent. B and K, those are both in the middle, so those two would have to be congruent, and then C and L are both the last letters, so those would have to be congruent. So we've already been doing this. We have just been given the congruent statement whenever we've used it so far. So in this problem, angle B, that is going to be congruent to angle K. With these, again, don't forget your symbols. And then BA, that's going to be congruent to segment JK. And when you're naming the segment, it is okay to flip the letters around so the order is different. As long as it's the same letters, it'll be counted correct. All right, so that part's not new. The new part is when we are going to be doing our proofs. With our proofs, we are still going to be following the first 4 steps that we've been doing this entire chapter. We're going to start with our given. We're going to use any vocab. Then we're going to look at the picture. And then we're going to use one of our 5 shortcuts to say that the triangles are congruent. Once you know the triangles are congruent, that is where our new step comes in, and that is going to be CPCTC. So 5 steps for our proof. You will know that you need to use CPCTC in your proof as the last step when you're trying to prove 2 parts congruent to each other. So we don't need this if we're trying to just prove the triangles are congruent, only when you are proving 2 parts are congruent. Okay, so in this proof, they want us to prove angle A and C are congruent to each other. In order to do that, first we're going to show the triangles are congruent, then we can use CPCTC. In this one, we'll go ahead, we'll start with our given information. AD is congruent to segment CD. Also, AB is congruent to CB. If they did not have this information marked in our picture, you would want to make sure you go ahead and mark that these segments are congruent to each other. So for the first pair, there's 1 dash on those 2 segments, AD and CD, and then the second pair, there's 2 dashes. And the reason marking the picture is helpful is it's going to help us figure out which one of our 5 shortcuts we're using. All right, this proof had no vocabulary, so then we're going to look at our picture. In the picture, we're looking for one of 3 things, or multiple if they have them. We're looking to see if they have parallel lines so that we can use alternate interior, alternate exterior, corresponding any of those. There are no parallel lines in this picture. We're also looking for vertical angles, and that is when you have 2 triangles that form an X in the middle, and so they would meet at an angle. That's a vertex. This one does not have any vertical angles. And then the third thing we're looking for is if there is a reflexive property. And reflexive property you use when there are 2 triangles using the same part. So if we look at the triangle on the left, and then we look at the triangle that's on the right, both of these triangles used line or segment BD. So the reflexive property is us just stating that segment BD is congruent to segment BD. That's our reflexive prop of congruence. So reflexive property is when you're going to have two of the same things set congruent to each other. Okay. So then if we look at our proof, we have a side, a second side, and then a third side that we have shown are congruent to each other. So looking at our 5 shortcuts, the only one that uses SSS or side, side, side is that first option that we went over. Once we know that, we can say our triangles are congruent. Now, they do not give us the name of the triangles in our proof statement, so we are in charge of naming them. So you have to make sure you're following the corresponding parts. So if I name the first one ABD, congruent to triangle, so A to B we went along the side with 2 dashes, and then B to D we went along the side with 0 dashes. So we'll start that same thing over here. C to B is going along the side with 2, B to D goes along the side with none. So C, B, D. And we talked about how that was side, side, side of congruent triangles. Now that we've said the triangles are congruent, we can say any of the corresponding parts are congruent to each other. So we could say that angle B is congruent to angle B, or angle, well, we already know all the sides, but the one that they're asking us to prove is angle A is congruent to angle C. So this one is going to work because of the corresponding parts of congruent triangles are congruent. So we're using exactly what we've been using before. We're just adding one extra step at the end. All right, let's go ahead and go to our next one. So I would recommend pausing and trying to do this one on your own and then comparing your answers. So again, we're going to start with our given. This one, it says BA is congruent to DA. Also, AC is congruent to AE. There is no vocab, so we are going to go right to the picture. All right, this one, they do not give us parallel lines. So in the given information, if they don't tell you you have parallel lines, you cannot use parallel lines because they didn't give them to us. There's no reflexive property because there's no side or angle that both triangles are using. So that only leaves us with the vertical angles. Now, A is where these angles meet. A has to be in the middle when you are naming them because A is the vertex. So if we name the angle that's on the left, we can name that angle CAB, or you could have named it BAC, as long as A is in the middle. And then the angle on the right, we can name EAD. And you could have named that DAE as well. And that one is just our vertical angle congruence theorem. All right. So then after our picture, we're going to see which one of our 5 shortcuts we're going to use. So we have a side, a second side, and then we have an angle. So if we look at our 5 shortcuts, we know it can't be side, side, side. To use side, the angle has to be in between the 2 sides, so where the 2 sides meet. And if we look at our picture, angle A, well, we named it CAB, is where those 2 congruent sides meet. So we are going to use side, angle, side as why the triangles are congruent. So I'm going to name a triangle CAB is congruent to triangle EAD. And that one is side, angle, side of congruent triangles. Once we know that the triangles are congruent, then we can use CPCTC to say that any of those corresponding parts are congruent. So we can say BC is congruent to DE. CPCTC. Okay, so make sure you have that all down before we move on to the next one. All right, so this last one, again, we're going to start with the given. This one, they told us angle BC is congruent to angle ACB, and they've marked that in our picture, so we're good with that. And angle K is congruent to angle A. All right, so then step 2, we have vocab. There's none in this picture, so step 3, we're going to look at our picture. So they did not give us any parallel lines. There are no vertical angles, but both of these triangles do use this one side. So I'm going to go ahead and say that BC is congruent to BC, and that is using our reflexive property. Okay, so then if we look at our congruent parts that we have so far, we have an angle, we have a second pair of angles, and then we have a pair of sides. So when we decide which one of our shortcuts we're going to use, we can't use side, side, side because we don't have 3 sides. Can't use side, angle, side because we only have 1 side. Can't use hypotenuse, leg because we need a right triangle. So that means we are either going to use angle, side, angle, or angle, angle, side. In order to tell the difference between which one we're using, we're going to look at the picture. So in one of our triangles, we have our congruent angle, and then the congruent side is outside of the 2 angles. So when we decide, we're going to choose angle, angle, side because the side, the S, is outside of the 2 A's. So we can say triangle KBC is congruent to triangle ACB. And that one was, angle, angle, side of congruent triangles. Once we have the triangles congruent, that is when we're going to use our last step, CPCTC. And again, you only use this when you're trying to prove 2 parts are congruent. So segment KB is congruent to segment AC. CPCTC. Okay. So that was the last section for this chapter. Make sure you fill in the notes, and then once you have that, they should be the last page of your notes. Once you have it filled in, you're going to show it to the sub in order to get your homework. Your homework is going to look like this. It's proof practice problems. So your homework is going to be 5 different proofs. So I want you to pause the video, go get them. And then I am going to kind of walk you through the first one. My first class had a lot of questions on this one, so I wanted to help you guys get through this. So once you have your note packet, you can hit play to go through the first proof. Okay, so hopefully you have your note packet. For these problems, this one we're just trying to prove that the triangles are congruent to each other. So that means we are not using CPCTC. You only use CPCTC when you're trying to prove 2 parts are congruent, and that would be the 4th one. This one we know we're trying to prove those 2 parts, so we would have to use CPCTC. These other ones, we're just going to use one of our 5 shortcuts because we're just proving 2 triangles congruent. So just like before, we'll start with our given. And this one, they told us that AC is perpendicular to BD. So remember, this sign here means perpendicular. They also told us AB is congruent to BC. Okay. And then we kind of have a vocabulary word for perpendicular. So perpendicular, where those 2 segments meet, so AC and BD, those segments are going to be forming right angles. So because the definition of perpendicular, we know those 2 angles where the segments meet are going to be right angles. And I'd strongly encourage using highlighters when doing these proofs to help you identify where certain angles are going to be that you are using. So for this one, we can say angle ADB, because D is in the middle, and angle CDB are right angles. And that is just our definition of perpendicular. And you can either write it out or use the symbol. After the definition of perpendicular, you are going to look at your picture to see if there's any information we can use from there. So in this picture, we don't have any parallel lines. We do not have vertical angles, but we do have a reflexive property here. We can say that DB is congruent to DB. And that is just our reflexive prop of congruence. Okay. So if we look at the information they gave us, they did tell us AB and BC are congruent. So let's go ahead and mark that in our picture. And then we said that DB is congruent to DB. So we have two sides that we know are congruent, and we also have a right triangle. So we want to check, is it possible for us to use hypotenuse leg? When you have right triangles, it's not always going to be hypotenuse leg, but you can use that one if you have the right triangles. And if we look at this picture, we have the right triangles, so we want to check the hypotenuse is across from the right angle. And we had the hypotenuse marked congruent in both of them. And then DB, that one is a leg. So it is okay for us to use hypotenuse leg because we know the longest side and we know one of the legs connecting to the right angle. So that gives us enough information to say triangle ABD is congruent to triangle CBD. And that one would be hypotenuse leg of congruent triangles. Okay, as you are going through the rest, again, I recommend using highlighters. Don't forget when we have a bisector, so this one's bisecting an angle, is going to tell you two congruent angles. I'm not going to tell you which ones. I want you to try to figure that one out on your own. But whenever we have a bisector that's bisecting an angle, it's going to give you two congruent angles. And the reason would just be the definition of angle bisector. Okay? And again, you use CPCTC when you're proving two parts congruent. So that's going to be the last two. All right. If you have any questions, we will go through questions on Monday. And Monday, we will also be working on the test review.